I'm sharing my screen. Okay, great. So just as a quick reminder, we've got our next test. So test number 2 is on Tuesday next week. Maybe I'll do this. Oh, all this time I was sitting here just waiting, and I did not set up my note. Oh, whoopsies. There, done. Okay, so test number 2 is on Tuesday, November 22nd. I was kind of thinking we have a review day scheduled for Thursday, but I think what we'll do, I'll be in my office if you have any questions, whether it be on Zoom or in person. Okay, but so class on Thursday is optional because I don't have any review questions or anything like that. Just if you have questions about the assignments that have been posted that you've been working through, because that's what I want you to practice. Okay. So bring questions from the assignments. I guess I could do them here. Let's see what's, yeah, I guess I didn't really, I'm just going off the cuff here. So class on Thursday is optional for review, but bring questions from the assignments, and we can work through them. Okay. If you don't have any questions, right, then you're good. Test questions will be from the assignments, just same as last time. So use the assignments for practice. That could involve some R coding. You'll be allowed to have R open, but I want to see that it's a blank page. So, and I'll try to set it up so that you don't have to use R, just kind of minimally. Okay. Any questions? I'll go back to Zoom here. Didn't really give you a chance to put anything in the chat, but I don't see anything in the chat, so I will go back. Feels like a long time ago. It was nice to have that long weekend, although I need another long weekend. Let's just do a smidge of review on tree classification models, just because we're going to use tree models again. Classification models. There was a credit example that we use, but just for an example, you might have a classification situation like maybe home twice. Maybe the biggest kind of classifier in your data set that the algorithm finds, right? We're not finding this, but we need to be able to interpret these things. So maybe if a person is a homeowner, right, that's either 1 or 0. right? If they are a homeowner, then maybe if the age is greater than 50, then maybe they're going to pay off their loan. If it's not, then maybe you check another condition, right? And another condition. And then maybe it's either paid off or default. I'm just making this up, but if they're not a homeowner, maybe you check if the age is less than 20 or something like that. Or maybe let's do 30 even. If the age is less than 30, then they're going to default on their loan. Oops. Pretty typical scenario here. Or paid off, right? That kind of thing. So here, what we can do is we can limit the number of nodes, right? Because this could just keep going and chisel down until it fits our training set perfectly. But we don't want that, right? We want it to fit the test set fairly well. Okay. And so we can limit the number of nodes right? And obviously this is in our R code, so that the branches, and maybe I'll say so that the tree not only fits the training set, right, but applies to the test set almost as well. So that the tree, or maybe I like what I have in my notes better. Sure. So the branches, feels like it's been a long day already. So that the branches are not specific to the data we use to build the tree. Wait, whoops. Right, in brackets, I'll say that would be the same as it fits the training set perfectly. But does not perform well. Oops. When applied to the test set. Right. Then you'd be overfitting the model. So what we kind of ended on is, okay, this tree model, once you kind of get used to reading them, then they're really easy to communicate and use as kind of a tool to communicate to your client how you've made these decisions, right? And so a tree model is a useful visualization of a classification model. You can use it for prediction too, but usually it's for classification. So maybe I'll say of a classification or prediction model that we can use if we're explaining the model to people who are unfamiliar with the data or even just data analysis, right? That happens. A lot of people just don't want to deal with it or don't understand it, and then to explain it. that we can use if explaining the model to people who are unfamiliar with the data or even data analysis. Or even data analysis. That's the end of our review from last day. So what's been found is, and there's, oh shoot, do I have it? Let me see here. Do I have it open? I think I was checking out some other stuff, but see it. Oh yeah, here it is. So kind of fun. From the textbook, I'll just steal it and bring it in here. Just as a way to illustrate kind of why we would use these ensemble methods, which is what we're about to introduce. So in 1906, the statistician Sir Francis Galton was visiting a county fair in England, at which a contest was being held to guess the dress weight of an ox that was on the exhibit. There were 800 guesses, and while the individual guesses varied widely, right? So we've seen this with the central limit theorem. Both the mean and the median came out within 1% of the ox's true weight. Okay, so we've seen that before, where, okay, even though our individual guesses are all over the place, right? If we look at the mean or even the median in this case, they were very, very close to the true weight, right? And so, James Surowiecki or Wiki wrote this the wisdom of crowds, which is basically what we're going to do when we introduce bagging. Okay, an ensemble of models, okay, is going to it's going to be more accurate, right? What's better than one model? Multiple models, right? Putting them all together and using the results of those many models than just selecting one model is going to be way more powerful. So what we're going to say here is to improve our classifications or predictions, right? But let's just focus on classifications. So to improve our classifications, I'll say slash predictions, I guess. We often need to consider multiple models. Need to consider multiple models. Okay. Or an ensemble of models, right? Multiple models, ensemble together, an ensemble of models. However, when we consider more than one tree, okay, it becomes hard or arguably impossible to visualize, right? Oh, well, I did a combination of these two trees. Those two trees could be completely different. They could use different predictors. They could be using different cutoff points, right? And so it's and then you do a mashup of the two, and it becomes very hard to visualize. However, when we consider more than one tree, it becomes hard / impossible to visualize the tree. It becomes / impossible, I would argue impossible, to visualize the tree. I'm sure people have tried. Oops. So kind of the first step into ensemble methods where we consider more than one tree, so multiple trees, is bagging, which is bootstrap aggregating. So bagging, wait. Bootstrap aggregating. So bagging is an ensemble method. Bagging is an ensemble method, which means it considers multiple models instead of just one. Considers multiple models instead of just one. But each new model is fit to a bootstrap resample. And so we're bootstrapping the data so we're always fitting to the same sample size. But remember, bootstrapping is when we're resampling with replacement, right? So we're creating a new data set essentially for each model that we build, right? But based off of the original data. But each new model is fit to a bootstrap resample. The bootstrap resample means that each model is built using a different data set. Each model is built using a different data set. Right? Generated from the original data set, obviously. Okay. So then what we're going to have is we're going to have all these models, and they're all going to make a prediction, right? So I give it some parameters that I want to use, and I want to generate a prediction. And so now each model that I have, let's say I've generated 100 models, right? 100 different models, then the bagged estimate is going to be the average of the models typically. The bagged estimate is the average, typically, of the models. Okay. So bagging is kind of our first step into multiple trees. Now the next step is going to be the random forest. So the random forest is bagging, but we're also, so instead of just bootstrap resampling, which feels like plenty, instead of just bootstrap resampling for the data that we build the models on, we're also sampling the predictors So it has that added layer of sampling the predictors as well. So we don't always use the same predictors. And so the random forest, wait, is a bagging decision tree which means it uses the bootstrap samples or resampling of the data. Bootstrap resampling of the data. Okay, and it randomly samples the predictors. That's kind of cool. Randomly samples the predictors. The predictors to consider for each model. It's this one. So if we're sampling the predictors, right, how many predictors are we going to sample at each model, right? As a rule of thumb, oops, that should say thumb. Oh man. There. We don't do anything. The algorithm sample the square root of p predictors. So just as an example here, if I have 20 predictors, which is perfectly reasonable, if p is 20, right, in a big data situation, you're going to have way more than 20 predictors, right? Then we would randomly sample around 4 or 5 predictors for each model. Now, what's super, super cool about the random forest algorithm is that it's able to detect which predictors are more important, okay? And it can even detect interactions that it should be including in the model, okay? And so that's pretty sophisticated, and I think that's pretty cool. And so the random forest algorithm has the ability to automatically determine which predictors are important. Which predictors are important. Oops. And can even detect interactions. And include them in the models. Include them in the models. I think that's pretty neat. So in the random forest algorithm, we can make some adjustments. We can adjust what we call hyperparameters, okay? And so we may need to adjust the hyperparameters, which are just arguments in our R code, to improve the estimates if the default settings are not giving us good estimates. Okay, and so we may need to adjust the hyperparameters, which are arguments in our R code. Right, we just adjust the code to improve our estimates beyond what the default settings can give us. Beyond what the default settings can give us. One thing that I will say here is this is something that we're going to be looking for as we get more comfortable. Of course, I would say in the beginning, if you're just using the random forest algorithm, just first glance, right, use the default settings and get used to the output, right? Get used to what you're looking at, right? And then you can say, oh, okay, well, what if I tweaked, which predictors to look at or something like that, right? There's kind of what if I tweak the growth of the trees, for example, right? So there's things that we can do, but adjusting these hyperparameters, we can also use that to prevent overfitting again, right? It's bad. So adjusting, oops. Adjusting the hyperparameters also helps prevent, helps prevent overfitting. So we've focused on, you've probably heard the terms bagging and boosting. They're both ensemble methods, okay, but we're going to focus on bagging, and we don't really need to do a lot of tuning. So adjusting those hyperparameters, we don't really need to worry about that so much. Whereas for boosting, the textbook kind of used the analogy of, okay, well, bagging is basically like driving, any normal car, just like driving a Honda, you just drive it. You don't really have to do a ton. Whereas boosting is basically like going to be getting behind the wheel of a race car, right? You better know what all the knobs do, and you better know what to do in a corner, for example, right? It's not just you get in and drive. So for those reasons, I would say, well, that's why I'm focusing on the bagging, because until you're very, very comfortable with bagging, I think you should not be doing boosting. Obviously, you should know what it is and just be aware. But until you're ready to graduate to boosting, it doesn't really make sense. So I'll say bagging / the random forest. Can be done with relatively little tuning. And of course, I say tuning, but tuning really means adjusting the hyperparameters. Whereas boosting, which we have not really talked about, boosting requires a lot of tuning, which means it requires a lot of practice. Okay. For this reason, right, boosting can be a lot more complicated. And like I said, you really shouldn't try to do it until you're very comfortable with the random forest and just bagging in general. Okay. And so for this reason, boosting can be a lot more complicated. It's not something you can't do, but unless you feel comfortable working the random forest, then I say don't try to do boosting. A lot more complicated, and we shouldn't attempt it until we're comfortable with bagging in the random forest. We are comfortable with bagging and the random forest. That said, there are many types of boosting that you can do. And they're all, the most common ones are in the textbook. Okay. So here's what I'm going to say about boosting. There are many different types of boosting. And I do want you to just kind of get comfortable with the different types. So see the textbook for some examples. Mostly just definitions, or only definitions for some examples. But in general, so what boosting does is it fits a series of models, but then each successive model also tries to minimize the error of the previous model. Okay. And it does some kind of fancy adjustments. So, but in general, boosting fits a series of models, usually trees. That's where we started, and we're still sticking with the trees. So usually trees, but each successive model tries to minimize the error of the previous model. Usually how it does it is it applies weights to the misclassified data, right? So it's trying to pick up on, well, those guys that I misclassified, who cares about the ones that I correctly classified? I'm going to keep correctly classifying them, but how do I pick out that misclassified data? Yeah. So minimize the error of the previous model, usually, not always, but usually by applying weights to the misclassified data. Weights to the misclassified data. that's all I have for my notes. Let me just see here if I had something. No, I think it was just the XGBoost, but you can read about it in the textbook. In terms of the definition, that's really all I'm looking at you guys for you guys. XGBoost. Now, I do want you to read it, but in terms of what we're going to be doing, I want to focus on just the random forest basically and bagging. I can't believe I have that much time left, but that's crazy. I'll go back to Zoom. If you have any questions, let me know. Oh. I haven't put the test together yet. But I'll do that and I'll know more for, I guess I made class optional for Thursday. Class is always optional, but but still, I'll post a little summary of the quiz on our Moodle page. So how about that? How about I'll set up, remember for test 1, I said there are 30 multiple choice questions. I'll do a summary like that and post it on our Moodle page once I've decided, because there are going to be some, they're not just multiple choice anymore. There are going to be some long answer questions. So I don't want to do 30, although you guys were really fast, but I don't want to assume that. Any other questions? No? I'll stop this recording here. All right. So for Thursday, oh, sure. Yeah, we can talk about that. But let me just finish the recording here. So for Thursday, if you have assignment questions, then you can bring those and we can work through those. But otherwise, if the assignment questions are all good, then you're all set for the test. So I'll stop the recording